Okay, our objective today is to be able to find the solution to a system of equations, but we're going to use a method called elimination today. Elimination is when you add or subtract two equations in standard form to eliminate a variable. Okay, here's our first example. The note here on the right says when you have opposite coefficients, you add to eliminate the variable. If you take a look at problem number 1, you see that the coefficients for y are -6 and +6. We have opposite coefficients. And when we have coefficients that are opposite, we add to eliminate a variable. Okay, so let's see what this looks like. When we add 5x and 3x, we're going to get 8x. When we add -6y and +6y, they eliminate. That's going to be 0. But I also have to add the right side of the equation here. -32 plus 48 is going to give me 16. I get a nice simple one-step equation. I'm going to divide by 8 on both sides of that equation to get x by itself. X is going to be equal to 16 divided by 8, which is 2. All right, we're halfway done. We want to be able to find y, and now I simply take my x, the fact that I know x is equal to 2, and I want to replace y in either one of these equations. I'm going to take x and replace x in that second equation, and that's going to look like this. 3 times whatever x is, and x is 2, plus 6 times y, that's going to be equal to 48, because we still need to find y. When we find a solution to a system, we're looking for the ordered pair, the value for x, the value for y, that's going to make both equations true. I multiply 3 times 2 is 6, so I have 6 plus 6y is going to be equal to 48. I want to solve my two-step equation, so I'm going to subtract 6 from both sides of the equation. That's going to give me 0. I'm left with 6y is going to be equal to 42. My one-step equation, I'm going to divide by 6 on both sides of the equation. We wind up with y is equal to 7. My ordered pair solution then would be 2, 7, but I want to do a quick mental check, and let's see if our solution makes both equations true. Replace x with 2, replace y with 7, see if I get a true statement. 5 times 2 is 10, 6 times 7 is 42. Is 10 minus 42 equal to -32? Yes, it is. We try the second equation, replace x with 2, replace y with 7, see if we get 48. 3 times 2 is 6, 6 times 7 is 42, 6 plus 42 is equal to 48. I know that that is the solution to the system because I've checked my answer. The value for x, the value for y makes the equation true, both equations true. All right, let's move on to example 2. My notes here say that when you have coefficients that are the same, you subtract to eliminate the variable. All right, let's take a look and see what that means. Notice here I have coefficients for y that are the same. I have 1y here and 1y here. When we have coefficients that are the same, we subtract to eliminate the variable. Now I'm just going to rewrite these. Let's not rewrite them. Let's do this. This is 1x minus 5x is going to be -4x. The y's eliminate. 6 minus 14, that's going to be -8. We divide by -4 on both sides of the equation. X is going to be equal to +2. I want to find y, so I'm going to replace x in one of these two equations. The first one looks very easy to use, so this becomes 2 plus y is going to be equal to 6. Subtract 2 from both sides of the equation. We wind up with y is going to be equal to 4. My ordered pair solution is going to be 2, 4. I want to check to make sure that this value for x and value for y make both equations true, so we check it quickly and mentally. 2 plus 4 equals 6, works for the first one. Let's try the second equation. Replace x with 2, replace y with 4. 5 times 2 is 10. 10 plus 4 equals 14. So I know that that is the solution to the system because it is the value for x, it is the value for y that's going to make both equations true. Okay, our third example. Now, are we going to use addition or are we going to use subtraction? Well, I see opposite signs here, but the coefficients are not opposites. So I'm not going to be able to use addition. But I see that I have the same coefficient here, 1x and 1x. Anytime I see coefficients that are the same, I want to subtract to eliminate the variable. 1x minus 1x is 0. They eliminate. 3 minus negative 4. Be careful with your integers. That's going to be 7y. 7 minus 14 is going to be negative 7. One-step equation. Divide by 7 on both sides of the equation. We get y is negative 1. I still need to find my value for x, so I'm going to replace y in the second equation. The reason why I'm going to use the second equation is because I notice that I have a negative coefficient here, and when I multiply a negative value for y by that negative coefficient, it's going to become positive. So it actually makes the problem a little bit easier to substitute in the second equation. That's just something you can, recognize. Could you use the first equation? Absolutely. But I'm going to use the second equation. I wind up with x plus negative 4 times negative 1, and that's going to be equal to 14. Negative 4 times negative 1 is positive 4, so we get x plus 4 equals 14. Subtract 4 from both sides of the equation. We wind up with x is equal to 10. My ordered pair solution would be 10 comma negative 1. My value for x is 10. My value for y is negative 1. All right, let's check to see if it makes both equations true. Replace x with 10, replace y with negative 1. 10 plus 3 times negative 1 is negative 3. 10 plus negative 3 is 7. Replace x with 10, y with negative 1. 10 minus 4 times negative 1 is negative 4. So 10 minus negative 4 becomes 10 plus 4 equals 14. So 10 comma negative 1 is the solution to the system. Let's move on to our third problem. Are we going to add or subtract to eliminate a variable here? I see opposite coefficients. So when I see opposite coefficients, I want to add to eliminate the variable. Negative 3 and positive 4, that's going to give me 1x. Positive 2 plus negative 2y, they eliminate. So x is going to be equal to 1 plus negative 3, negative 2. I mean, how easy is that? I want to replace x with negative 2 to find y. I'm going to use this first equation here. So this becomes negative 3 times negative 2 plus 2 times y. That's going to be equal to 1. 6 plus 2 times y is going to be equal to 1. When we subtract 6 from both sides of the equation, I get 2y is going to be negative 5. And when we divide by 2, on both sides of the equation, we wind up with y is going to be negative 2.5. My ordered pair solution should be negative 2 comma negative 2.5. Let's check it, make sure it makes both equations true. Negative 3 times negative 2 is positive 6. 2 times negative 2.5, that's going to be negative 5. Is positive 6 plus negative 5 equal to 1? Yes, it is. 4 times negative 2 is going to be negative 8. Negative 2 times negative 2.5 is going to be 5. Is negative 8 plus 5 equal to negative 3? Yes, it is. Okay, we have a bunch of problems to do here. Will we add or subtract to eliminate the variable here? I don't see coefficients that are opposites, so I see coefficients that are the same, so I know I'm going to have to subtract to eliminate the variable. 2x minus negative 2x, they're going to eliminate. That's going to be 0. 3 minus negative 2, that becomes 5. Y. 6 minus 4, 6 minus 4 is 2. Solve for y, we divide by 5 on both sides of the equation. Y is going to be equal to 4/10 or 2/5. I want to replace y in one of these equations. I'll use the first one. We want to find x. 2 times x plus 3 times 4/10. is going to be equal to 6. 2x plus 3 times 4/10 is 1.2. It's going to be equal to 6. Subtract 1.2 from both sides of the equation. 2x is going to be equal to, what's that? 4.8. Divide by 2, divide by 2. Y should be 2.4. Oh, I'm sorry, x is 2.4. Your ordered pair solution is 2.4, comma 4/10. Let's see if that makes the system correct. 2 times 2.4 is 4.8. 4.8 plus 1.2, that equals 6. Second equation, 2 times 2.4 is 4.8. 4.8 minus 2 times 4/10 is 0.8. 4.8 minus 8/10 is going to be equal to 4. So it works. Okay. Now we move on to another type of problem. Notice the little note up top here says, you may use multiplication to help eliminate a variable. Find a common multiple. When I look at this system here, I don't see coefficients that are opposites, and I don't see coefficients that are the same. So I wonder, well, what can I do? Well, I can use my properties of mathematics. I have my multiplication property of equality, which says we can multiply both sides of an equation, and the equation still remains true. I notice that I have opposite signs here, and I always like to eliminate with addition. So I'm going to try to find a common multiple of 4 and 2 that's going to allow me to eliminate with addition. Okay? Well, common multiple of 4 and 2 would be 4, so it looks like I simply have to multiply this second equation by 2 using my multiplication property of equality. Right? And let's see what happens here. 2 times 5x is going to be 10x. 2 times 2y is 4y. 2 times 18 is 36. I use my multiplication property of equality. I multiply both sides of the equation by the same number. The equation is going to remain true. I simply recopy this top equation now. 3x plus 4y is going to be equal to negative 10. And now I can use addition to eliminate the variable. 3x and 10x is 13x. Your y's are eliminated with addition. When I add the right side of the equation, negative 10 and 36, we get 26. I have a one-step equation where I'm going to divide both sides of the equation by 13. We get x is going to be equal to 2. I still want to find y, so I'm still going to use substitution. I can substitute for x in either one of those equations. I'll use the second equation. That's going to give me 5 times whatever x is, and x is 2, minus 2 times y. That's going to be equal to 18. 5 times 2 is 10. Minus 2y is going to be 18. I have a nice simple two-step equation. I want to subtract 10 from both sides of the equation. I wind up with negative 2y is going to be equal to, what's that, 8. Divide by negative 2. Divide by negative 2. We wind up with y, oops, be careful there, Palata. Y is going to be equal to negative 4. My ordered pair solution should be 2 comma negative 4. Let's check it. Has to make both equations true. 3 times 2 is 6, plus 4 times negative 4 is negative 16. 6 plus negative 16 is negative 10. 5 times 2 is 10. Negative 2 times negative 4 is positive 8. 10 plus 8 is 18. Right? We always want to check our solutions. Make sure that your solutions make both equations true. Let's look at example 7. I can eliminate the p's. I can eliminate the q's. I see that if I multiply this top equation by negative 2, I would have opposite coefficients because negative 4 and positive 4p, they would be opposites. I could eliminate with addition. So this top equation becomes negative 2 times 2p, negative 4p, minus negative 2 times negative 5. That's positive 10q. And then 6 times negative 2 is going to be negative 12. Recopy the second equation. 3q, negative 1. And now we are eliminating with addition. Your p's eliminate with addition. 10q, 3q, 13q, negative 12, negative 1, negative 13. I like anytime I get those friendly numbers, q should be equal to negative 1. I want to find the value for p, so I can replace p in either one of these equations. I'm going to use that top equation to find p. 2p minus 5 times negative 1. It's going to be equal to 6. I want it with 2p plus 5. It's going to be equal to 6. I subtract 5 from both sides of the equation. 2p is going to be equal to 1. And when we divide by 2 on both sides, I want it with p is going to be 1/2. My ordered pair solution is going to be 1/2, comma, negative 1. I want to check my answer. Replace p with 1/2. Replace q with negative 1. Okay, and let's see what that's going to look like. Okay, 1/2 times 2 is going to be 1. 1, negative 5 times negative 1 is 5, so 1 plus 5 is going to be 6. 4 times 1/2 is 2. 2 plus negative 3 is going to be negative 1. It checks. Okay, just a few more problems to do. This problem's a little different now because now I have to multiply both equations by some number. Okay? If I want to eliminate the p's, I can multiply the top equation by 3 and the bottom equation by 2. I'd have coefficients that are the same. They would both be positive 6, and I can eliminate with subtraction. I always like to eliminate with addition, and I see if I want to eliminate the t's, I can multiply the top equation by 2 and the bottom equation by 3, and I would have opposite coefficients. So that's what I'm going to do. Multiply by 2, multiply by 3. So here we have to multiply both equations by some number. Let's see what happens. Keep it black. 2 times 2p is going to be 4p. 2 times negative 3, negative 6t, and that's going to be equal to 8. 3 times 3p is going to be 9p. 3 times 2 is going to be 6. That's t. That's going to be equal to 18. We are adding to eliminate the variable. And when I add, I wind up with 13p is going to be equal to, they eliminate, that's going to be what? 26. Divide by 13. Divide by 13. We wind up with p is going to be equal to 2. I want to find t. I'm going to replace using the second equation, but it doesn't matter which one you use. 3p. Nope, that's 3 times 2. Nope. Getting a little careless there. 3 times 2. And my computer's having a little trouble keeping up. Means I'm going too quickly, Pilata. Slow down. 3 times 2 plus 2 times t. That's going to be equal to 6. 3 times 2 is 6. 2 times t. It's going to be equal to 6. Subtract 6. Subtract 6. I want it with 2t. It's going to be equal to 0. Divide by 2. Divide by 2. T equals 0. Your ordered pair solution, 2 comma 0. We check it. 2 times 2 is 4. 4 minus 0 equals 4. 3 times 2 is 6. 6 plus 0 equals 6. It works. All right. And now we get to an example that's a little bit different from the others. It's called an identity. You don't know it's an identity yet, but as you go about solving the problem, you're going to see what we're talking about here. If I try to solve this problem, I think I would eliminate the x's by multiplying this bottom equation by negative 2. So I'm going to recopy the first equation. All right, 6y, that's going to be equal to 18. and then multiply using the multiplication property of equality, multiply the second equation by -2. So we get -2x, what's that, -6y, and that's going to be equal to -18. When we add to eliminate the variable, we have opposite coefficients, but look, your x's will eliminate with addition, your y's will eliminate with addition, and here we also eliminate this with addition. I get a true statement. 0 is the same as 0. That's an identity. That means then that there are an infinite number of solutions. Infinite solutions. All right, there are an infinite number of solutions when you have an identity. Right? So those are nice and simple when we recognize that. And that's going to happen sometimes. Anytime your both variables eliminate, so your x is eliminated, your y is eliminated, if we get a true statement here, 0 is equal to 0, or if I had 12 is equal to 12, or 5 is equal to 5, we get a true statement, it's an identity. Here, let's see what happens with the next one. No solution, huh? All right, what's that going to look like? Well, right off the bat, you can see that we have the same coefficients here. -2 times a number plus 5 times a number equals 7. -2 times a number plus 5 times a number equals 12. Using intuition, you know that that just cannot be true. That being said, let's see what happens. If we subtract to eliminate the variables, because we have same coefficients here, they're going to eliminate, and they're going to eliminate with subtraction, so I get 0. 7 minus 12 is going to be -5. 0 does not equal -5, right? So that is an example of no solutions. There are no values for x and y that are going to make those equations true, or make that system true. All right, guys, we're all done for today. I know that as per Amaya's request yesterday, she asked for a video recording, so this one's for you, Amaya, and hopefully this helps you guys out a little bit today. All right, enjoy the snow. Talk to you later. Bye-bye.